The Strait of Hormuz sits between Iran and Oman. At its narrowest, it funnels all commercial shipping into two lanes barely 6 miles wide. Every day, roughly 20 million barrels of petroleum liquids and 1/5 of the global liquefied natural gas trade move through this water. That represents over $500 billion worth of energy, traversing a single point of failure every year. Iranian military doctrine explicitly threatens to block this transit if their own exports are restricted. They have routinely demonstrated this capability, notably seizing the British-flagged Stena Impero in 2019 and holding the crew for 2 months. Later that same year, a coordinated drone and missile strike hit Saudi Aramco's processing facility at Abqaiq. That single attack knocked 5.7 million barrels of daily production offline, causing global crude prices to jump nearly 20%. Protecting this region requires enormous investment, like deploying multi-billion-dollar carrier strike groups. Yet expensive navies consistently struggle to neutralize asymmetric threats like $35,000 drones and cheap sea mines. This chart shows the structural deficit facing energy markets today. Existing bypass pipelines in Saudi Arabia and the UAE can reroute 5.5 million barrels per day. That leaves an unmitigated gap of 14 to 16 million barrels locked to this single maritime passage. A prolonged closure of the strait is projected to cost the global economy up to $3.5 trillion. Because military deterrence cannot guarantee the safe passage of commercial vessels, the only secure path is building physical infrastructure that circumvents the water entirely. The immediate strategy relies on upgrading existing steel. Saudi Arabia and the UAE already operate bypass routes, but they are constrained by port loading limits. Expanding terminal capacity at the end of the Abu Dhabi crude oil pipeline in Fujairah and the Petroline in Yanbu directly subtracts millions of barrels from the street's daily traffic. Over the next decade, new projects aim to expand this network. Iraq's cabinet has approved a 1,700-kilometer pipeline to Jordan's Red Sea port of Aqaba, and engineers are evaluating the dormant Iraqi pipeline through Saudi Arabia for rehabilitation. Looking at our chart again, completing these pipeline upgrades pushes total bypass capacity to roughly 13 million barrels per day, dropping the structural deficit down to around 7 million barrels. However, a massive portion of this remaining volume is Qatar's liquefied natural gas, or LNG, natural gas that has been cooled to a liquid state for shipping. Currently, there is absolutely zero pipeline infrastructure anywhere in the world capable of bypassing the strait for LNG. It is strictly trapped by the geography. Recognizing the limits of Gulf pipelines, buyers are remapping their energy grids to avoid maritime transit. China has spent years establishing overland corridors. The Power of Siberia pipeline now delivers up to 38 billion cubic meters of Russian gas directly into China by land, securing over a quarter of their gas imports without requiring a single ship. The proposed India-Middle East-Europe corridor applies the same logic. By integrating hydrogen supply chains and electricity grids across Jordan and Israel, future energy can flow directly to Europe without passing through traditional maritime choke points. Laying new pipe and redrawing trade maps successfully cuts the physical deficit by more than half. Yet, engineering alone cannot eliminate the remaining millions of barrels still bound to the strait. The absolute surest way to solve the remaining deficit is by destroying the demand for the fuel entirely. American shale production hit a record 13.2 million barrels of crude per day in 2024. The United States also became the world's largest exporter of LNG, providing Asian and European markets with a massive, reliable alternative to Qatari gas. Simultaneously, electric vehicle adoption is heavily compressing the need for oil. EV sales in China are projected to cross 50% of the market in 2025. By 2030, electric vehicles globally are actually on track to displace 5.4 million barrels of oil demand every single day. Because of this shift, China's total oil demand is expected to peak in 2027. Paired with the construction of over 30 new nuclear reactors across Asia, the baseline requirement for imported fossil fuels is falling fast. When global consumption plateaus and alternative suppliers flood the market, the remaining volume of hydrocarbons trapped behind the strait naturally shrinks. No combination of current technologies can fully replace the Strait of Hormuz overnight. It remains the most critical energy passage on Earth. But this final chart shows the convergence of the three-pronged strategy.
When we subtract the new pipeline capacities, the influx of alternative LNG, and the daily barrels displaced by the energy transition, that massive initial deficit shrinks to a highly manageable sliver. By distributing the energy load across multiple geographies and power sources, the geopolitical leverage held by the strait is severely diluted. A potential closure goes from a catastrophic threat down to a manageable supply chain disruption. This chart weighs $50 billion in pipeline costs against a $3.5 trillion hit to global GDP if the strait closed. Spending billions on steel pipes and renewable grids acts as the premium for a global insurance policy. It ensures that the world economy will no longer rely entirely on a single 6-mile stretch of water.